Hey, sixth grade. So everybody has this little packet about motion graphs. Remember, we have been working on speed, direction, time. Speed is distance divided by time. And you have been working on these and how important it is to a graph. And we learned about on one of the former videos that speed and slope are sort of the same thing, and distance and time. Now, those that were supposed to be in class, we did an activity about graphing, so you may not have any issues with the little packet, but I'd like to make a video for some of the remote kids that might struggle. Remember, you can call me anytime during my office hours during the day from 8:30 about till 9:10. If I happen to step out to use the restroom or what have you, just leave a message and I'll call you back. Some of them, I think it was cohort B, when I reassigned this because so many kids came without it done, I added just these two. So let's answer these a little bit. Here, question 8 says, during which time period was the car moving the fastest? Now, since the slope, or what sixth graders would call the steepness of the line, is the speed, I would say when it first started. So between like 0 seconds and 4 seconds would be the answer here. He would be the fastest. What was the speed of the car during the first 4 seconds? Well, when we're going to factor speed, that speed equals distance divided by time. So I can use a graph to find that out. So we already have time, 0 to 4 seconds, the first 4 seconds. Now we have to figure out the distance. So we just go up to this graph and look at the distance. The distance was 4. So what is 4 divided by 4? It would be 1 meter per second. So the answer here is 1 meter per second. Remember, we talked in class about if the line here is going horizontal, let's think about what the graph is showing you. Time is passing, but this person is not going anywhere. When they reach the, let's call it the 4-meter mark, they stood there. So maybe they caught their breath or they stopped to talk to somebody when they were jogging, and then they began to go again. Now, we do know that it's slower. I know it's slower just by looking at the slope or the steepness of the line. But if I wanted to, I could go ahead and calculate the speed from here to here. Once again, this is 4 seconds from 8 to 12. And in that 4 seconds, they went from 4 meters to 6 meters. So it's not 6 meters. They only increased by 2. It was the same 4 seconds. So they went from 1 meter per second to about a half a meter per second. And we didn't have to do the math. We could just tell that by the steepness of the line. So I'm going to set that aside, knowing that you've read it and you looked at it, you understand it, and you didn't ask any questions. Okay, so it is, I don't normally like to give a lot of packets, and it's really not. This is just information. Listen, what motion, speed, velocity, and what this word acceleration means. Tells us the rate of speed and direction changes. So believe it or not, even when you slow down or turn a corner, since your direction or your speed has changed, scientists call that acceleration. So there's always that distance and time, and it was really cool. We called it space-time in class, and how Albert Einstein worked with that. That time always passes. It is increasing to the right, but since the distance didn't change, we say the whatever object it is either at rest or stopped. Here's some more information when you're looking at a graph. We did some sample graphing in class. A constant speed is shown at the right. So you could think about a graph paper, you'd be doing it the same exact because the line is nice and straight. A steeper line, or one with more of a slope, would have a higher speed, so it would be here, and as it would slow down, time would still pass, but you would be, think about this, you would be going less distance. So think about the other lab that we did. If speed slows down, it would not be as far as speed and distance are directly proportional. Time would keep passing. We didn't really graph this one, this little curvy line here, but this would be accelerating or increase. This is similar to what we did in class, which was we just put all of these different types of lines on one graph. We did not do this, but this gives you more information. There's really nothing to write on what I would call the first 3 pages. Okay, so I'm going to kind of hide my answer here, and it's only one question. Which of these graphs shows one of the runners starting 10 yards ahead of the other runner? So this would be the places where they start. You would pick either A, B, C, or D, and then you would just explain your answer. I am going to hide my answer on this one too. And let's look at this. This says, which of the following graphs below are both runners moving at the same speed? So we're looking for lines that demonstrate constant speed. They might have started at different spots, but they're both running the same. You need to pick that. Now, what I wanted to point out to you is instead of going A, B, C, D, like it would be normal, it goes A, B, D, C. So be careful when you choose your answer. I just kind of wanted to point that out to you. So far you've only had to answer 2 questions, and we're done with page 5. Page 6, once again, down here, you know what, I should get a blank copy. Of course, I don't have one here. Let me see. Okay, I don't have a blank copy, so I'm going to fold this back here. I pulled out my key here. All right, so down here, there's 4 scenarios. The car is stopped. Which graph seems to show a car that is not adding any of its distance? So you would put graph, let's say you thought it was graph E. Down there you would say graph E goes with number 1, and then you would tell me why you think that on the bottom. I think I'm going to pause this and go get another copy. So now I have a copy I can talk about here. So if you thought number 1 went with maybe C, you would write graph C matches description 1 because, and you could go ahead and talk about the line, you could talk about distance and or time, whatever you prefer, but you definitely want to have some reason there. Okay, so let's say we're on page 6 now. We've 2, 3, 4, 5, 6 questions. So even though it's a packet, it's not really a whole bunch of work, I don't think. So I like this one. It's just look at the graph. This is something similar we use. We do have some circles here, but they really want you to use time, which was in seconds, and distance. You can feel free to use a calculator when you go to figure out the average speeds. Remember, average speed is total distance, total time. So you got to find Albert. How far did he run, and how long did it take him to run there? So you're going to kind of explain where you find that. Now, this is the next couple of pages are what we're going to call a little bit more challenging. It's a little bit more in depth because now when we're talking about looking at a graph, teachers always tell you how important it is to label your axes. So I'm going to go here, and we talked about this in class. I want you to take a look at this. It looks very similar to the other one, but I'm going to tell you right now, number 5 is not this one, because if you look, we have time down here again, but the other one is speed. So this is how fast you're traveling. So think about a graph showing you this person is speeding up because time passes, that word time there, and this is how fast you're going. And let's just say this was 1 and you wrote it all the way up to 100, then that one would be this person is going faster. So be very careful on that. Notice that it says speed and not distance. On the next page, the same thing happens. We have a graph that has different lines. Normally, if it's a flat line, we would say the car or somebody stopped. But this is speed. speed, which means their speed has not changed. Look at point A. Point A, it says, is going 10, let's say, miles or meters per second. That's not changing from A to B. It's not. That both of them are going that. So be careful when you're reading the axes labels. And once again, here you can feel free. If it asks you to calculate anything, you can use a calculator. It says choose the correct words from the following list. So I would be looking for these words. They introduce the word decelerating. So accelerating in science is both speed up and slow down, but in this case decelerating would be slowing down as well. It's because we want to be thinkers. When it says segment OA, we're talking about this segment right here. What's going on there? What's going on here? Kind of told you. What's going from B to C, what's happening from C to D, what's happening from D to E. This is an introductory skill. A lot of times when sixth graders go to plot things on a graph, soon as they get it started, they just continuing it. This introduces the idea that things very seldom travel at constant speeds. We talked about calculating our average speed when we're going on a trip. You might go 70 miles an hour to Cleveland, but you did not pull out of your driveway, drive down your street, and go through the downtown Hubbard going 70. You went from maybe 5 to 10 to 25 to 35 to 45 to then going on the on-ramp to get on 80. So have a good time with this. Remember, this I'm giving a week to do, so take your time on it. I've had kids get it done in 20 minutes, but I assigned it for 2 days at home, and then you can turn it in when you come back, or if you need some more time, you're going to be asking me some questions this Thursday and this Friday, and then you can turn it in the following Monday and Tuesday. Remote kids, feel free to call. Thank you. Have a great Wednesday.